Right. So listen, I thought we'd finish up this week with some and finish up circles with some really kind of thought-provoking ones, as I say. So we've had a look at some epic ones, but these ones are a bit more fun, I think. So the y-axis and x equal to 8 are tangents to a circle. And this circle's center lies on the line 2x minus y minus 3 equal to 0. And we need to find the radius, the center, and the equation. So as usual, I'm going to give you a 3, 2, 1. Give it your best shot, and then we'll come back to it. 3, 2, 1, go. And we're back. Okay, so like I think these ones are really, really, really fun. Okay, you know, you mightn't think they're fun, but I think there's something about them. You know, you can have fun with them. You can, you know, you can explore little things about them. So let's do the obvious one. Okay, so the center, or sorry, the radius. Well, the y-axis. Let's visualize the y-axis. There's the y-axis there. Okay, and then let's visualize, you know, x equal to 8. Okay, so there's your x-axis. So x equal to 8 would be somewhere out here. So the circle is sandwiched between those 2 points. I don't know exactly where it is. I don't know its center, but I do know that one end of it is at there and the other end is at there. So that's a distance of 8, which means the radius is a distance of 4. So that's pretty obvious. Okay. So the next thing, find the center. Interesting. Well, we know one part of the center, that's for sure. Okay, one part of the center contains x equals 4. We just need the other part of the center. But we're told something, aren't we? We're told that the circle center is contained in this equation. So if 2x minus y minus 3 is equal to 0, and we know 4 has to be part of it, because that coordinate there, if I bring it right back down to the x-axis, that's 4 comma something. I don't know what it is, but that's what it is. Then if I put 4 in there, I should get the y component. So that's 8. 8 minus 3 is 5. 5. So y is equal to 5. Okay, so y is equal to 5. So the center of my circle is going to be 4, 5. So not too bad. We're so far so good. Now we have to find the equation. Well, like, you know, I mean, there's lots of things you can go at here, but the reality is you have everything you need. Okay, so you've got center x minus 5, x minus 4, y minus 5 plus square them equal to r squared. Okay, so there you go. You know, I wouldn't say it's a tough one, but to me, it's not a tough one, but I could see where people could get really, really, really stuck, because if you don't visualize them, and that is key, visualizing these are a kind of key component to making these work. If you don't visualize them, you're not going to get them. Okay, so we'll try a tougher one. Okay, so hope that was just kind of a tease for a really tough one. Okay, so let's say that the y-axis is a tangent to the circle x squared plus y squared plus 2gx plus 2fy plus c equal to 0. I want you to prove that f squared is equal to c. That's the first thing I want you to prove. And then if the circle touches the y-axis at 0 minus 3, okay, careful of that now, 0 minus 3, and contains the point 4, 1, find the equation. Now, there's a quick way of doing this. Of course, there's going to be a quick way of doing this, and then there's a slow way of doing it. But listen, we're going to do a 3, 2, 1. You're going to give it your best shot, and we will see where you come out at the other end of this one. Okay, so 3, 2, 1, go. Okay, so how do we prove that f squared is equal to c? Well, if it's hooking the y-axis, that means we look at the other one. We know that the radius is going to be equal to the absolute value of minus g. Okay, so going to be easy to figure out. But anyway, let's have a look. So let's expand that out using our identity. The square root of, yes, you got it, g squared plus f squared minus c is going to be equal to absolute value of g. Square both sides. G squared plus f squared minus c is going to be equal to g squared. Cancel the g squared. So f squared minus c is equal to 0. F squared is equal to c. So you've proven the point that you're asked to prove. Okay. Now they're obviously telling you this for a reason. We're going to use this, obviously, this identity, but you know, it's good to see it done anyway. Okay, so how are we going to use this identity? I hear you shout. Well, what do we need to know? We know that 0 minus 3 is the point at which it touches, and it contains 4, 1. So what we're really missing is the center, isn't it? We just need the center because we can work out the radius if we can get the center. Okay, so if it's the y-axis is a tangent at 0 minus 3, well then, you know, the f value has to be, for want of a better word, has to be 3, doesn't it? Okay, has to be 3. Okay, but listen, we can look at that a different way. Let's say you didn't know that. How would you figure it out? Well, one way of figuring it out would be to do what we did in the previous video. Let's put 0 and 3, 0 and minus 3 into our generic equation. Okay, so if I put 0 in, there and there, that's gone. We'll get a y squared, what we get, sorry, x squared plus, that'll be a 9. We'll get a 9 minus 6f plus c equal to 0. Okay, so let's rearrange that. Minus 6f plus c is equal to minus 9. So we'll get that. Now let's do the same thing by substituting in 4 and 1. Let's put 4 1 in here. We get 16 and 1 is 17. Bring that across, that's a minus 17. And then we're going to get a 4 and a 1. That'll be an 8g and a 2f and a c. 8g plus 2f plus c. Now, they don't help you, but we know something else. We know, drum roll, because we were asked to prove it, that f squared is equal to c. Okay? So if f squared is equal to c, well, I already have c here. Couldn't I substitute it in? That's minus 6f plus f squared is equal to minus 9. That looks to me solvable. Let's rearrange it. F squared minus 6f plus 9 equal to 0. That's 3, isn't it? F and f, 3 and 3, and they're both minuses. So f is equal to 3. F is equal to 3. If f is equal to 3, then 3 squared is 9. Then c is equal to 9. If f is equal to 3 and c equals 9, put them in here, and let's have a look. 9 plus 6 is 15 minus 32, so that would give me a g of minus 4. G is equal to minus 4. G is equal to minus 4. So now I have f, g, and c. Let's put them all together. X squared plus y squared minus double that, 8x plus 6y plus 9 equals 0. Hope you can see that. If not, I shall move it. There you go. Was there a quicker way of doing that? I believe there is a quicker way of doing that. So what we could have done is, well, the f value is going to be 3 anyway, straight away. Okay? It just has to be. Okay? So remember, and let's see, what else could I have figured out? Then I could have just subbed that in and just, you know, at the f, I'd be just solving for the, you know, the g and the c. It'd be the same thing, but you'd just be doing it backwards, I suppose. Yeah, you know what? Listen, you got your answer, you get your answer. It doesn't make a difference how you do it. But yeah, personally, that would be the way I go at it. Right, so listen, there's just a short little video on two little kind of, I wouldn't say they're hard, but they're more thinking ones. We have to do a little bit more thinking. Okay, right, well, listen, that brings us to the end of the circle. Everything else in the circle is just a mixture of all that, unfortunately, and it is a big old mixture of everything there. Okay, so like anything else, it's just a matter of, for me personally, the easiest thing to do is to visualize them. Visualize them. Okay, and give them your best shot. Okay. I think we know. Let's know what. We'll try another one, just for the fun of it. And given, let's have a bit of fun with one of them. Okay. Here's one. Okay. So you will like this one because you know I like these ones. Two satellites orbit the Earth. One has an orbit of x squared plus y squared is equal to 2, 2, 5, 1, 2, 3, 4. Okay, 2.25 million. Okay, the second one is 200 kilometers further away than the first. Now, here's the question. How much further does the second satellite travel? Ooh, nasty. Okay, now the assumption here has been that the center of the Earth is a 0, 0. Okay, so both are concentric circles around the center of the Earth. We know that's not true, but let's go with it at that. Okay, so let's think about this one for a second before I let you rip. Now, some of you might just go straight into it and think, I know this one. I'm gonna nail this one very easily. Okay, so what we need to do is figure out first of all the radius of the first one. Get his distance, then we can tag on a little bit to get the second one, and we get the diameter of both of them, and we take the two diameters away, and we figure out the extra bit that he's having to travel. Yeah, I think that's the way we'll go on this one. So let's take the first one. X squared plus y squared is equal to r squared. So what's the square root of 2, 2, 5, 0, 1, 2, 3? Okay, I'm going to get out Mr. Calculator for this one. I'm assuming it's a nice number. I think it's over about 1,500 or something like that. Square root 225. Yeah, 1,500. So the radius, the first one, is 1,500 kilometers. Okay, let's get the diameter he travels. Diameter is 2 pi r. Okay, so it's multiplied by 2, multiplied by, I'm going to give it in terms of pi, 3,000 pi. Okay, diameter. Sorry, no, circumference. What am I on about? Circumference. Circumference. So we'll talk about diameter. Now let's take the second one. So the second one is going to be 1,700 kilometers because it's 200 kilometers further away. So that's 1,700 multiplied by 2 multiplied by pi equals. So it's 3,400 pi circumference. Let's take the two of them away. Minus 3,000 pi, 1256.6 kilometers more. The second fella has to go. Okay, or to 1257 to the nearest if you're rounding up or whatever. That's a nice one, isn't it? That's a pretty cool one. I think that's a nice one. I wouldn't consider that one crazy. Okay. Right. I can't really think of anything crazy on this one. Right. We'll do one more because I'm in the mood for doing some fun things. Okay. So have a look at this. This is a square. Okay, everyone with me so far? A square. This is 2 and 7. And this is 8 and 7. Okay. I want you to find the coordinates of C and D. That's the first thing. Okay. And this, right, this is where we're going to have fun. I then want you to find the center of a circle that passes through all four and I want you to find the equation of a circle that touches on the inside. Right. This one is, I love these ones. This is going to be such fun. Right. So let's think about this one for a second. Okay. What do we know for sure? This is the x and this is the y. This is the x and this is the y. So the distance between this x and this y is 6. Okay. So this has to be 2 and this has to be 2. Sorry, this has to be 8. Okay. Now, if the distance between those two is 6, then the distance between those two has to be 6. So that's uno and that's uno. So 2, 1 and 8, 1 have to be the bottom bits of it. Okay, so that's your first thing done. You found your coordinates. Now, I'm just trying to think. First of all, it's going to be pretty easy to find that center. Okay, finding the coordinates of that center, it's the coordinates of both of them. It has to be. Okay, because we're symmetrical here. So if you think about it, I'm going to dig out my compass just to show you if I can find it. So, you know, whatever one that goes from there to there to there to there, okay, it's the same circle that's going to go from there to there to there to there. It's the same center, so it's common to both. Now, there's a couple of ways we could do this. You know, logic would dictate that you can find the x coordinate of it pretty easily because we know that it's a distance of 6, which means that, you know, if it's 6 across, then this has to be 3 from this side and 3 from this side. So it has to be at 5. So it's definitely 5 and something. Okay? And the same thing here. If it's a distance of 6 from there to there, then it has to be 3. So it has to be 4 because you're adding 3 to get to the middle, then another 3 to get to 7. Okay, so 5, 4 has to be the center of our circle. The question though becomes really then, how do we figure out the largest circle that could possibly fit in? Okay, right, let's think about it then. That circle can only have a maximum radius from there to there. So it can only have a maximum radius of 3. Okay, so 3 from there to there because it's 6 right across. So the radius can have a maximum of 3. So now we have a center and a radius. So it's x minus 5 to be squared plus y minus 4 to be squared is equal to 9. Has to be that circle. Now, there is a way of figuring out that one, that bigger circle. Okay. We're not asked to do it, but I'm just wondering, let's spitball it. Okay, what do we know for sure? Haha. Okay, what we know for sure is that this shape is a right angle triangle. And this is 3 and this is 3. So you can work out the radius of that one. Okay, it's going to be 3 squared plus 3 squared. That's 9 plus 9 is 18. It's root 18, which is root 2, I think. So it's going to be x minus 5 to be squared plus y minus 3 to be squared is going to be equal to 18, I think. Okay, don't quote me on that one, but I think that's what it is. So there you have it. That's a pretty cool one. Okay, that's, to me, that's real fun. Okay, that is super duper fun stuff, because what you're doing there is you're just using all your different kind of I don't know what you call them, all your different, you know, skills. I suppose that's the word I'm looking for here. You're using all your different skills that you've ever used in every type of, you know, scenario to work it out. Okay, you know, it's a pretty cool one. Personally, I think it's pretty cool. Okay, right, that's it. I will see you the next time.